Hello and welcome to Fall Through, your source for deep conversations about technology, software, and computing. I'm your host, Chris Brando, also known as Scriptable, and on today's episode, it's, you guessed it, another Matt and me one, and we have a couple of topics that we're going to talk about. We're going to pick up where we left off with that conversation about Bryan Cantrill's talk and where we feel Go fits on the revolutionary to rebellious spectrum. We have some thoughts on Apple's new hardware, and of course, we're going to chat a bit about some AI stuff. As per usual, we will have supporter-only content for our wonderful supporters. If you're not a supporter already, please go to fallthrough.fm/subscribe and become one today. It's not only better audio, it's also more content. Who doesn't love more content? And if you're not already, please give us a follow on social media. And if you're watching on YouTube, hit that like and subscribe button. It really helps us a lot. And with that, let's get into the show. Hello, viewer/listener, and welcome back to Fall Through. Once again, Matt and myself. It's just a dynamic duo here. Although we should be getting some new people in. Talked to Ian the other day. Ian's going to be back on the pod soon, hopefully. But today it's Matt. How are you doing today, Matt?
Good. I mean, I've done nothing to get the guests that I said I was going to get on because baby things are imminent, and I'm just like, there's a list. There's an ordered list, and there's just things to do. But yes, I have a list of people I want to bring on. It's just, did I want to put the effort in before the baby's here? No. I didn't want to put the effort in.
I mean, you're having a kid, you have a job,
yeah,
you have a podcast. There's a lot going on. So.
There's just a lot of coordination. So I'm just like, You know what? We will have these conversations. It just has to happen after baby. I did ask Jared from Changelog to come on. He said he's game to come on in the summer. So
okay.
That'd be cool.
Yeah, that was a bit of shocking news, I feel, of just like Jared being like retiring from Changelog to go pursue something new. I'm like, oh, wow. Kind of thought that him and Adam and that whole thing were going to just be a forever thing, but.
Yep. I was kind of shocked. I was like, wait, this came out of nowhere for me,
Yeah.
But good for him. I mean, you do need change. He did about 15 years, I guess, there, more or less. Ish.
Yeah, I think it was like quite a bit of time.
Yeah. And like there's so many podcasts now, and there's like podcasts are a lot of popularity contest based stuff, right? Like it's if you have a large following and you're popular, your podcast is good, quote unquote, but you can talk about nothing. Like yeah, I get it.
No, I definitely like the Changelog podcast. Just I don't have a lot of podcast listening in me like these days. It was the one thing before. I don't know. I guess like I don't go as many walks anymore, so it's just like I don't have a whole lot of time where I want to like sit and listen to podcasts. But Changelog was always one of the top.
I used to listen to it on the commute into New York City. Just sit on the train, throw a podcast on.
Yeah.
In the spring, summer, I listen to more because I cut the grass, and that's like a perfect time to throw a podcast episode on. But in the winter, I'm just like, I'm with you. Like I'm either here or at the gym or whatever, and I don't really have time to put the podcast on. Like, yeah. So it'll be interesting to see what happens with Changelog. It seems like Adam is still continuing forward with all of it, so it'll be slightly different without Jared behind the scenes. But yeah, and he wrote a very nice like goodbye letter to everybody, basically, which was nice. I was like, oh, this is so nice. That was really nice. I read the blog post. It was just it was nice. The Zulub chat was very, can't say welcoming, but kind. What's the opposite of welcoming on the way out? Like, you know what I mean? Like welcoming is like kind on your entry. What's the like kind on your exit? I don't know.
Wait, where was it talked about in the Zulub chat? I just completely missed that.
In the episode title one, so I think it was a finale and friends, or was it?
Oh,
yeah.
I think I'm probably just not in that channel. So I was looking in like the general. Oh yeah, so probably
it's under friends and then finale and friends.
Yeah. Ugh. Oh my goodness. Yeah, finale and friends. Oh, look at you crying. So
I put the sobs. I said sob.
Yeah.
I like both of them. I think the Changelog is a fantastic podcast. I think Jared and Adam are both great, and I'm not sad, but I'm sad.
Yeah. No, it's definitely one of those again, I just kind of thought he'd be there for like forever.
Right.
And then he just, but we all gotta move on at some point too. I mean, I guess
you can't be a lifer anymore, like for anything. Like this is something I try to tell some of my friends too. Like I'm just gonna be a lifer at XYZ company or that. Like no, you're not. Like that's not the best thing you can do in your life is like keep your skills up and keep yourself up so that you can adapt to the changing life.
Yeah.
You can't just rest and invest anymore. Like that's just not how life works. Not even just work, but in any area of life. You have to keep yourself ready for the change.
I do want to come back to Bryan's talk, The Complexity of Simplicity, because I went and watched it, and for good measure, I also watched Simple Made Easy after that. And you, listener/viewer, if you have not watched or listened to Simple Made Easy by Rich Hickey, you should absolutely go watch it. It is phenomenal how he just breaks down the language and the terminology to actually get at the heart of the difference between simple and complex and easy and hard, and why those terms should mean distinct things and all of that. But I definitely, after watching Bryan's talk, I was very convinced that Go squarely belongs in the rebellious quadrant. Probably very deep, like very much to like the bottom right corner there. Very rebellious and very simple, at least at its inception. And for the first many years, that was very much the type of language and system that it is and was, right? Almost every big problem that would not allow you, like any problem that might complicate or complexify the language, that would, as Rich Hickey would say, that would complex the language, was kind of kicked right down the road, whether that be error handling or whether that be generics or even package management, dependency management. All of that was just like kicked out. And it was like, maybe we figure this out one day, maybe we don't. We're going to scope it outside of the scope of the language and this system. And that made for a very simple, elegant system. And I think Go has lost a lot of that along the way. I think we've managed to add generics in very seamlessly. But I think there's other things that required this same amount of effort that didn't really get added in well. And I think that's because we did not, I think the way, interestingly, this is why I think it was also very interesting as a language. Go as an ecosystem itself, very emergent. I think it lives squarely in the rebellious section. But I think whenever we want to fix the big thorny problems with Go, we shoot directly up into the engineered realm. And we, as Bryan would say, start with a clean sheet of paper. I think that's what they did with generics, right? They said, not how does everybody else do generics, but how do we do generics for Go? And I think whenever Go does that clean sheet of paper thing and says, what is it that, put everything out, pull what Go has as context in, and then build a solution from that. I think when we do that, we come up with good solutions. I think when you look at one of the problems that Go is having and you try to make a rebellious solution to that, I think that's when the problems come in. Because Go did a lot of its rebelling in the creation of the language itself, right? The idea of how you can simplify things and really make it so that you can have large-scale engineering teams build stuff, even without a lot of the assumed complexity, right? What is, as Bryan would term it, what was thought to be essential complexity that is actually accidental complexity. And I think part of the problem is that a lot of that accidental complexity was rang out of the language. So any other complexity that's there is probably essential complexity. And I think there are probably ways to remove some of that essential complexity as well, but it just takes a whole lot of engineering effort to do that. And I think, our favorite topics to be like, I don't think it worked that, modules. But I would also say iterators are another one where we needed to take more time and energy into finding a clean paper solution, which would have meant probably a great deal of work on the runtime. But I will say this, I do think that Go is unique among pretty much any other language. I can't really think of another language out there that has the opportunity that Go has to continue being both rebellious and revolutionary and embodying those two things.
Why do you say that?
Because I think like, Go.
Not that I don't agree or whatever. I'm just curious of where you're coming at from that.
Yeah. I think for Go specifically, right, it's a language that doesn't need to have a fully built solution to ship. It's definitely is this thing correct for the constrained way we want it to be correct? Okay, great, ship it. And I think that resolves some of the problems that revolutionary systems have, where you're like, okay, when do we ship? How do we constrain scope? All of that. Like the rebellious nature, the let's actually get something out there for people to use nature of the Go ecosystem is the kind of the constraining force on that revolution, right? Like we didn't wait until we had figured out how to do, generic interfaces, or add generics to interfaces before we launched with generic functions in Go, right?
Right.
And now that we have a reason for having generic methods, we're not waiting to have generic interfaces to launch with generic methods in Go, right? And it's not like I don't think that's a weird thing. Like nobody's sitting here being like, well, we shouldn't launch this. Or I guess there's not many people sitting here saying we can't launch this thing until we have all of the work done. It's, well, we got the piece of it done that will help people. So let's get that thing out there. And I think when you have an ecosystem like that, you can really reduce those clean sheet of paper engineering projects to much smaller scope, which means you can get them done, kind of get them out the door faster. And if you mess it up, think about the kind of emergent way the language works. There's a lot of space to go back and fix things if you get them wrong.
Right.
Right. Because it's like it's not a system that's built from the ground up with, these foundational ideas baked into the foundation. It's like, no, we're adding these ideas in over time, and the idea wasn't there from the beginning. So obviously, if you pull it out, it's not like the whole thing's going to collapse because the thing was existing before and it didn't have that. So I think that's what makes Go probably one of the most important languages that we have in the industry right now. And I think the reason why I think many of us have felt so down on it for so long, and I think the reason why people keep, legitimately asking, why Go when there's TypeScript? Why Go when there's Rust? Why go when there's Zig? Why go when there's Python? Why go when there's, ad nauseum languages? I think the reason is because they're looking for a language that does a specific thing instead of looking at a language for the benefits it gives to the ecosystem as a whole, which in Go's case is Go has proven over time that it can get all of us to really rethink how everything works. And where Go does the worst is when Go tries to chase after what other people are doing, or when Go takes the ideas of other people and just implements them. And I think that's
without like thinking about it.
Yeah, without doing a rebellious thing, right?
Yeah.
Without doing a rebellious or revolutionary thing, right? Like, how does this thing reduce the complexity? And I think, we modules is just the easy punching bag because there's just so many things that are awkward about it, but like the attempt to reduce the complexity in modules was an attempt to reduce essential complexity, like literal essential complexity to how you work with SemVer, instead of reducing the actual accidental complexity of having SemVer at all, which is an interesting use case as well, because like Go didn't use SemVer before. I mean, like we had with like Dep and GoDep and all of those things, but like most of us weren't using SemVer, and we built Kubernetes and Docker and all of HashiCorp stuff.
Right.
That all got built before we were doing versioning. And so it's like, we added in semantic versioning, and that's when things got a lot more difficult to work with. So it's like we tried to strip away complexity not from what existed in Go, but from what existed in a solution that we were all trying to import into Go. And I think like that's the place where we tend to misstep a lot. And the lesson we can learn from that is like, let's stop trying to be like everybody else, and let's actually start pulling out those clean sheets of paper and solving fundamental problems. Let's not look at what everybody else is saying and be like, oh, we got to fix that. Let's actually dig a little bit deeper and figure out what the actual problems are.
I think like people confuse let's stop trying to be like everybody else with like, let's not look at anything else for inspiration. Right.
Yeah.
Like they people have this tendency to like speak in absolutes, right? If you have friends, if you have relationships, you've heard this, like you're the worst, or like you always do this, right? Like people speak in absolutes. We do it. Everyone does it. It's okay. Yeah. But there's that tendency to like let that go unchallenged. And when you say like, oh, stop, I don't want Go to be like everybody else, it's not in totality, it's like, hey, don't just blindly implement these things because someone else told you to, or that's how something else works. Look at those things for inspiration and be like, hey, listen, people are really liking these things from like Rust and Python or whatever, right? They're liking these things. How would that look in Go? That's how you have to think about it, right? Not just like, hey, put Rust enums in Go, or like change error handling like this or whatever. You have to think about what's the core problem here, what's missing, and how could I build the solution to this that fits with the mantra of Go or the mantra of whatever I'm working in.
Yeah.
And that's a much harder conversation to have, because then you open up to everyone's opinions and blah, blah, blah. But it's the conversation that needs to be like, it needs to be had.
Yeah. Yeah. I do think the other failing of our community, man, I wanted this to be a much happier podcast episode. Sorry, listener. I think the other, like the thing that we all need to reckon with is that I honestly, and I said this on Blue Sky when I was talking with somebody, like, we need to cut the appeal to authority crap that we've been doing. Like, we need to stop being like, we want some official solution from the Go team. Like, let's just be real clear here. The Go team is great at some things. They are great at designing a compiler and a language runtime. They're okay-ish at maintaining the standard library. I think there's probably too much stuff in the standard library for them to be maintaining it, for them to be like the people that have the last call on things. But I think there are a lot of things that they're really, really good at, and most of them have to do with building and maintaining a programming language and that really small scope of things. And I think when you ask, about, hey, how should I structure my project? Like, they're not going to be able to give you a good answer to that. They're not in an environment that's going to be able to give you a good answer to that. Even like, how should I manage my dependencies? They don't have dependencies, right? That's the thing about building the language itself. You don't really get to have dependencies. Like, sure, in the X repos, they have like a few dependencies, but they're not building stuff with a lot of dependencies. That's not what's allowed in the language as they've laid it out, right? So they're not going to be able to give you a good dependency management solution, just like they're probably not going to be able to give you a good solution, kind of how we brought up before, on like, what's the best paradigms for using databases? They're not really building a lot of applications that use databases that are kind of off the shelf in public, right? You want to have solutions from the people who have the most knowledge. This is something that like the U.S. military learned a while ago. Actually, they learned during the Iraq and Afghanistan wars that it's like, you can't have the generals and the people at the top who are thousands of miles away and time delayed making decisions about what to do on the ground. You have to have the people with the most knowledge and the most context be the ones who make the decisions. And that means like the people that are on the ground actually deciding, okay, we're going to make these movements, we're going to make these strikes, we're going to do these things. The same is true of how we should do things in the community, right? We as a community are the best people to give suggestions on how to structure your code. We're probably the best ones to build a dependency management tool, I think, ironically. We're probably the best ones to give advice on how to build good database integrations, right? Like, I think SQLC, I think that's a great tool and a great thing that got built. And it's like, we shouldn't expect the Go team to go build something like that for us, right? The Go team is small and very resource constrained, and they should be focused on making the garbage collector better and making the runtime better and making all of these other things that we need them to make better,
right?
Not focusing on stuff that they don't have enough context to really resolve that well, right? I think there was
my brain was like, did he just say SQLC? For the longest time, my brain was like, why did he say that? But no, you're totally correct. I know, like in our last episode, we talked about like how, we want more of an official source for some of these guidances, but I think we didn't say that too explicitly, like not from the Go team specifically. Like, I don't think we were as specific when we said that, but yeah, it doesn't have to be from the Go team specifically. Like, and like you're saying here, it can't because they actually don't know what that looks like, because their environment is different than our environment. Like, the builder of the tool is not always the best person to tell you how to use the tool in a way, right? Like, they're like, maybe something motivated building the tool in the first place, and they built the tool and they had their use case, but then after the tool is built, new use cases will come up, and like, it's up to the community to decide how best that tool is used. And that's kind of where we're at with Go, right? Like, they built it, like Go was built to take advantage of multi-core systems, right? That was one of its guiding principles. Also, to be simple so that it can you can onboard developers quickly and get them going with the language, right? Like, these are things that people have said, that the creators of the language have said. And That's different than the problems that you and I have to use Go for and to solve in our businesses, right? We want to use it to create web services or APIs or CLIs. And really, like, how much Go code is actually using multi-threaded stuff? Right? Like, at the end of the day, like, specifically, I don't mean like, oh, I spun up an HTTP handler and behind the scenes it's like doing things. You as a Go programmer, you're making a CLI. You don't care about some of these things in a way.
I mean, it depends, right?
Depends on what you're building, for sure.
Yeah.
But
it's like, I don't even think I don't even think they meant for like multi-core stuff. I think, I always go back to Rob Pike wanting to build making it easier for large enterprises to build software efficiently, right? Large software chains being able to build software in the large. I think like they definitely achieved that in the early days, right? And I do think that the standard library that we have now made a lot of sense for the early days of Go, right? Where you had, because it was a place where just like a whole bunch of people were just contributing, and you kind of had these different factions of places where people were focused on maintaining that specific thing. And I think the Go team was a little bit bigger, so had more of those people and had people that had been working on a whole bunch of different stuff. So I think at the time, the standard library as it got developed made a whole lot of sense for how it got built out. But I think in the long term, probably what we needed was something more like what Zig has, which, remember, Mitchell on I think the latest episode he was on with us talked about how the Zig standard library really only has the stuff that you need to build Zig itself, right? So like things that the compiler needs in order to be a good compiler, basically, with maybe like a few other things that are like essentials. And I think that's probably, when your community grows larger, and you do have a dependency management solution, I do think that's the more ideal path to go. But I think for a long time, when we didn't have the best story on dependency management, putting the crucial stuff in the standard library, telling people to just copy code instead of trying to have like some dependency that you pulled in some other way, like those are really valuable and good pieces of advice.
Right.
But that's not advice that works well when you're like, oh, we have a dependency management solution. It's like, okay, well, now the calculus on that changes a little bit, because now it is easier to pull in dependency, or at least theoretically easier to pull in dependencies and keep them up to date. And that changes the ecosystem in some important ways. And I think Go needed that, but I don't think the way that it happened has benefited Go in the way it needed to. I also think that the way of getting things in standard library now is a bit clunky. Like, I think the crypto UUID package is causing a lot of headaches for some community members and frustration over like how clunky this integration has kind of been. Like, I sat down, I started reading through that thread, and I was just like, dear Lord, this is this is a lot of, I guess, like sometimes people talking past each other. Maybe that's another. There's like so many threads where I'm just like, I don't understand why we can't get on the same page here about things, or why we're not saying, okay, let's not put anything in the standard library if we can't come to a consensus as a community. Like, what happened to that, and how do we rebuild all of that? But I do think all of this kind of not so happy stuff said, I still think that Go sits in a very, very, very important part in the industry as like probably one of the most important programming languages out there, because of what we can do if we can figure out how to come together as a community. I think that's the main thing I'm trying to say here. It's like, stop trying to appeal to everything being written by the Go team or blessed by the Go team. Like, they're not your mom and your dad. Like, I get, we have complained about paternalism for so long. They are not our parents. Please stop pretending.
Yeah, we are teenagers at this point. It's time for us to go take the language.
We got to rebel a little bit. We got to stop like asking for the blessing of mom and dad for things. Like, stop looking at them as the arbiter. We as a community need to come together and actually be a community and figure out how to resolve conflicts or disagreements in a healthy way. Because we need to have the ability to have solutions without someone at the top telling us this is the blessed solution or whatever. And that is very much a we should return to where we were before, which is really tough, because there was a period of time when we did have that, and then that got bulldozed, and the Go team decided to like take reign and like hold power with an iron fist, and now we're dealing with the outcome of like that not really working out so well. But the power in that is all of us. Like we can fix that. And I do want to keep saying that like Go is a very important language. And I am not down on Go. That's not what this is. This is me saying, imploring everybody, like we need to come together as a community and really take our own power back, because we have lost too much of it. We've given up too much of it, and the power lies with us. So,
amen. Amen. See, you get it. This is why we talk about things on the podcast. I mean, honestly, like, you know, I like doing interviews with guests. I like having people on, but sometimes it's nice to just talk with somebody else and get your thoughts out there and refine your thoughts over time. The more you talk and be like, you know what, actually, I've thought about this now for a while, and here's my line, and here's where I'm at. And I like that. I think we're doing a good job of that. And I know our listeners are probably like, shut up already. But really, like, I'm sure all listeners are also agreeing, right? I've defended Go having a strong standard library for a long time. And I was like, hey, this is perfect. Everything's in language. But then that sucks when changing it is hard. Like I want to make a change to the standard library and I can't because you control it, not me. And you're sure I can like fork it or do my own package or whatever, but there's that too. But it's like, and then I look at Rust and I'm like, okay, you have this sort of crates, you know, this crates model where everything's a crate. There's not a lot in the standard library. You're supposed to call in a crate for everything. But I kind of like that now in a way, because now I can change those crates a little bit easier. It's not as baked into the language. It's just different. And your opinion kind of changes over time. But then I like Go's simplicity. I really like the way I can use Go routines and, you know, write powerful programs pretty quickly. Maybe they're not fully correct, but they're powerful, right? Yeah. And I see that little sweet spot. I'm not down on Go in the way. I want to see Go. I don't want Go to be like that one friend who like peaked in high school, you know? Like I want them to have a good adulthood.
But I also think it's interesting because I was like, well, as we're talking about this, I'm kind of thinking that like part of me does wonder if the standard library did used to be much more community controlled. Like part of me wonders if so much of this is just like the formalism that's gone into it. I mean, there was definitely the big move that happened, maybe it was 8 years ago. I don't remember. It was a while ago, where Google was basically like, someone from Google has to sign off on every patch that goes into the language. I think that definitely did some, I don't know if it did some harm, but it like definitely like prominent community members, I remember seeing at the time, posting something mailing was like, hey, can someone from Google please +1 this so I can merge it? And that like wasn't an issue as much before. So I think like also like the context has now changed, where it's like the standard library is now like a very Google controlled thing because it's part of the language, which is the default implementation of language is a very Google controlled thing. So it's not a resource that the community can really own. And it is something that like the Google and the Go team and whatever conservatism they might have around putting things in, because then they're on the hook for maintaining it and all of that, which I think is fair. Like I think they should be, you know, more strict about what goes in the standard library because they do wind up on the hook for whatever is in there. But right. I do think that the other side of that is that we as a community need to have our own community resources. Like we need to have a community centered library then, where we can bring together and be like, here is the recommended stuff for things X, Y, and Z, and have a way to actually build up the infrastructure, which usually a registry would take care of for us. But this is an area where Go can rebel against everybody else and actually do some clean sheet of paper revolution of like, we got to figure out a way to build a community centered library without a central registry. Like it can't just be something that is like centrally controlled by some entity. It has to be something where all of us come together and we figure out a way to be like, hey, here are the recommended libraries that you use. Oh, you're trying to do, you know, OAuth, you're trying to do a database thing, you're trying to do this, you're trying to do that. Here are the libraries that we're going to suggest that you use. Right. Right. Because I think like that's what we need at the end of the day, especially if we want to scale. Because, you know, you can't... If it's going to require a +2 or +1 or whatever from someone at Google, that's obviously always going to be a bottleneck for any type of large scale maintenance. So like, I think we as a community, we just have to come up with better solutions. And it'd be interesting to have a new and novel idea about how to do this. It doesn't require a foundation or a company or like something so centralized. Like we should have something more decentralized so that so it's not, you know, it doesn't run into these problems that seem to happen quite often.
Right.
Whether it is a company or a foundation or another type of entity. So I think that this is an area where like we should all come together and we should all be pushing to build something interesting and really rebuilding our community on that foundation. Because yeah, Standard Library has some legacy in it. So and
yeah, yeah, it does. There are things that I would like to change about the Standard Library, and like I don't know, the cheeky answer is like, okay, then just go contribute. But like that's not really an answer sometimes either, because not everyone has the time to contribute, and quite frankly, the contribution process for some things are a little wild, a little much. You know, it's.
I mean, I'll be honest. Every time I look at an issue queue thread, I get a little exhausted just from the like. It's not. I really wanted this to be a positive episode. I'm sorry, listener. It's
maybe it's probably my fault. I did it. I did this.
it's all Matthew's fault. If you want someone to blame, because I was here to talk about.
Yep.
I'm here. Like I think Go is like the most important language in the industry, and we need to actually do a lot to like build it back up into its glory because no one else is doing the things that need to get done. And you're over here being like, so, therefore, it's all Matthew's faults.
Is that how I sound? That sounds good. I like that one. I could do that.
But no, like I look at the issues and I'm just kind of like, oh my God. Like I think it's a combination of everybody being a little exhausted, a lot of people talking past each other, people arguing from completely different contexts. And I'm like, y'all, we need to figure out how to fix this because I don't feel like this is how it felt before. And maybe that's just because I've changed and grown, but it did not feel this way in the past. So I think it's, I want us to fix that.
Right. Me too. Like I don't know. I talk to people like, oh, I'm going to go for con. Like, no, I'm not going to go for con because baby. And it's like, oh, but at least I'm missing to see you there. Like, I want to be there too, but also I didn't find the last one to be worth it outside of seeing people. Like. I don't want to go to a conference just to see people that I can see otherwise. Like I still want to go for the thing that we're all connected about. Like right. I want to go for Go, right? And like I just didn't have a desire to go for Go, and I want that to change because I want to. I'll put a positive spin on this. Before I moved out of Florida and back to New Jersey, I took Bill Kennedy's Ultimate Go class. In person, right? So like at his office down there, like that's where his company is. In person, he's teaching, and it was an amazing experience. Like Bill has all the energy. He's like the gopher man. My wife calls him. My wife, that's the gopher man with the because he has little sticker with the hat, right? Like the gopher man, and it was an amazing experience. Just energy was amazing. Excitement about the language is amazing. Like it's just you felt like you had this power at your fingertips to really just do things and change things. And Go is on its like nice upward trajectory, right? Like more and more companies using Go. This is like HashiCorp's glory days at this point, right? Like, well, and it's just where is that, right? Like where is that excitement? And I'm sure new people coming to language might be having that excitement. Maybe I don't know. I can't speak for the new people anymore, but I was excited to go for con, to meet these people, to talk to them about Go and see where Go's at. I was excited to go to these training events because it was just like I can up level my Go skills. And I went to Gotham Go, which hasn't had a thing in a couple of years now, I think. And it's just fun. People were excited to be there. And now what's up? Like I want that back, right? I want that excitement back. And it seems like Rust is the community that has that excitement now. And it's like, why? Why them, not us, right? And like Go is still a very capable language. We can fix this. Like we can change this. The Go for Slack doesn't have to be quiet, right? Like we can do better with this stuff. And I'm sure there are other language communities that feel similarly. Like, do you think that the Java community is bumming like or buzzing? Probably not. But I don't know. I'm not in that community. Yeah. I'm in the Go community, and I don't want this to come down to a point where it's like, actually, I'm going to exit the Go community because I'll still write Go, but I'm going to exit the community. I don't want to get to that point because it's I agree. It's an important language for what it's done to the industry. And I think that's why, like in Bryan's talk, I think that's why he put it in the revolutionary category, with the note of it can be on the line between Rebellious.
Yeah.
Because it really is an important language. It got a lot of people into the field. It really boosted along with the cloud sort of computing era. Like it was just there. And now it's like, I don't think twice about using it sometimes.
Yeah.
Right. And I don't mean that in a good way. Like, I mean that in the bad way of not thinking twice. Like I don't actually want to reach for it unless I have to. And like, I don't want that feeling.
I feel like, so I think that, there are some people that are working on Go stuff that are doing absolutely brilliant stuff. Like I've brought it up so many times before, but like Alan Donovan and co.'s work on the analysis framework and how really beautifully that whole system is designed, I think is like a really good example of the kind of model that we should be going forward with, right? Like the Go team doesn't need to build stuff for us anymore. That's not really what we need. We need the infrastructure so that we can build stuff, right? So it's like the analysis framework gave us the infrastructure so that things like static check can do so much more, but so that you can also, right? Like it's feasible for you to build a single binary that can run 1,000 analysis checks. And before, that would have been you having to run 1,000 different binaries. And if one of your analysis tools actually needed the output of another one, well, hopefully it's going to shove out the output in a way that can be input into the other tool. If not, that other tool just has to redo the work that other tool was doing. And now in your CI system, you're trying to orchestrate 1,000 different calls and all of this to do the analysis processing, and they're all spitting it out in slightly different formats. You got to bring that all together, and then it's just like, that is a giant mess that is solved by having a comprehensive, well-designed analysis framework. And now it's like, oh, you want to run this as standalone tools? Okay, you can do that because you can have a single function call that turns your analysis library into analysis executable, or you can just have all of your analysis, libraries, and you can put them all together, and it will automatically order them and put outputs into inputs and all of that stuff, and build the DAG that you need to do the execution and run them efficiently. And it's like a single binary that you compile and then run, and like that completely changes the scope and how scope of static analysis and how many static analysis tools you can run, and like how you can choose which ones you want to run and which ones you don't want to run, and how and when and all of that. And like that, I think like that's honestly, like in the last 5 years, I think that's one of the things that I've been like the most excited about. Like I was really, really, really wanting that work to get done. I was following it. I was super excited to see it get into the language, but I think it's a part of the language that like has just been very quiet for people. And like Alan Donovan's been doing like amazing work on Go for like well over a decade now, right? He gave us Guru, which was also one of those. I think that was really a revolutionary tool. It really only worked in the Go path context. Really, it got weird when we added modules. It like completely broke, but it was a tool that would let you just like easily find references. And this was like before language servers were like super popular. So you could find like callers and referrers and do all this other cool static analysis stuff on everything in your Go path. Like, and you could like root it at a specific part of your Go path, but it was like this really powerful tool. He also wrote EG, which allowed you to have like, oh, here's an example of the code that I have, an example of the code I want to replace, and you use actual type information instead of just grepping or search and replace to be like, okay, no, this is the same instance of this thing. I'm going to replace it with this other thing, which is also just like a really cool tool. And like those ideas have been rolled into like the inliner, which is now what powers Go Fix. And like now we have this ability to do all these Go fixes along with all of the static analysis stuff. Like that whole story, I think, is one of the most Go-like things we've had in the past decade, right? Because that is looking at the status quo, rebelling against it, but also kind of doing a little bit of revolutionary work. It's not just we're not going to do static analysis the way everybody else is doing. It's we're not going to do static analysis the way everybody else is going to do. We're going to start from a clean slate and rebuild the whole thing and make it so it's an integrated, nice experience for everybody involved. And that's the type of stuff that I want to see more of. And I think that's the type of stuff we should be talking about more and should be getting more attention.
Can you extend Go Fix? I actually have never used it.
Extend in what way?
Like when would I care about Go Fix? I've never used it. I actually don't even know what it really does under the hood. Is it something that I can like? Right
now it's pretty constrained from what I understand. But you can do some. I think there's like a Go Fix inline directive, so that basically if you have a library and you're like, okay, well, like let's say you're going from one version to another, you have both versions sitting in, and the old version is implemented in terms of the new version. You can put a go fix inline. Well, I don't know the exact syntax, but you can put that statement there. And then when you run go fix, it'll actually update the call sites to use what is inside that function. So it'll just kind of replace the function call with whatever's inside of it, which is a way to just upgrade your code over time by using go fix.
So you have some level of like, I can use this thing. I can like control the compiler in a way. I can tell the compiler something.
Yes, it's still static at the static analysis level, but yes, you can make it so that you can update your code by running go fix in the same way that you could before, or the same way you run like go vet or go func or any of those.
Yeah. So
like,
it's before the compiling step. It's okay. It's just raw static. Okay, got it.
Yeah, it's rewriting your code for you.
I had no idea. I never used it. I never researched it, so I was just curious.
It's like a really cool tool. I think it has the seeds of really interesting ideas for the future. But that's definitely like one of the. I'm like, this is such an awesome thing. I want more of that, and I think we're gonna need more of that if we're ever gonna fix errors. So,
if it's good,
yeah. But no, we can talk about errors. You want to talk about errors? Because I came up with something. It's gonna kind of wait to write about it, but I'm kind of feeling like, I just want to talk about it.
I'm happy to talk about errors.
So yeah, error handling, right? So I was thinking about this the other day. And I think error handling is another area where, much like SemVer, the whole industry has kind of gotten this wrong, and Go is uniquely positioned to get it right. But I do not think we as a community will like the answer that I'm going to propose, but I do think it's probably the correct answer. So in error handling, right now, I think the big problem is that the way that we do it, right, is that we say, oh, I'm going to write my function or my type. I'm going to lay out my types for the return values that are the happy path, right? You have your nice struct and all your fields and all of that. And then you have your return types. You're like, okay, my beautifully architected types for parameters, my beautifully architected types for returns, and then error. And I'm like, okay, that error type is giving you nothing, right? Yep. It might as well be any, right? Because I don't think anybody uses the error string you get back to actually do any type of error handling. I think it'd be a foolish thing to do because that is so brittle.
We do it in testing probably, like assert.
Yeah, you kind of assert on the string, and that is still brittle. It's gross. We've tried to do all of this stuff with like wrapping errors and all of that. And I just want you viewers listening to imagine if instead of it being, the nice concrete type you've created, comma error, if we just had an interface in Go called value, and just had a method on it called capital V value that returned a string, right? And if every single return of any function method you called just gave you back that object, because we made that interface. Do you think Go would be a nice language to work with? No, it would be awful to work with because you'd have this useless thing you get back from every single function and method, and you would have to type assert on it or build some other weird contraption around it to try and figure out what's in there. You'd have no idea what types of function or method might return. It's incredibly difficult to get static analysis to tell you what that answer might be, right? It would be a colossal, disgusting mess. It would smell. It'd make Go smell awful. Right. And that is exactly what the error interface does. The error interface, unlike most of the other useful interfaces, it's not like the IO reader interface, for example, right? IO reader interface is good because you call the read method on it. That is what you do with it. You don't care what's underneath it. If you do, you type assert on it. But the reason you say I'll take an IO reader is because you want an IO reader or a byte reader or a writer or whatever. You want to call the methods on that interface. None of us are calling
behavior. Yeah. Right? You want something that can read.
Yes. We want the interface for its behavior.
Right. And then what is the error interface's behavior? To error?
Yeah. To give us a string? That is not helpful.
To error, exactly. Yeah.
That's not the thing we want. Even if we could use a string, that's a terrible interface for trying to define something, right? What if I want to know if this is retryable? Do I have to grep the word retry and all of its derivations out of this string?
Well, no, you're supposed to put you're supposed to implement the error with a concrete type and then type assert it. And then now anytime, and I can't stand that. Even with the helpers that were added to the language, wrapping and other is and as or whatever, I still have to match against all these cases.
Well, And this is the thing,
and
right?
create a variable.
This is the thing. I think everybody's been right for the longest time that if error does not equal no return error has been a smell. It has been the smelliest of smells.
Whoa.
But
who are you?
Error.is and error.as, all of that is all a smell too. All of this is a smell. And everybody's like, we need to have try or this or that. And I'm like, you're trying to Febreze your way out of the most stanky garbage that is in your house. And you know what I do in my house? When I have bad smelling garbage, I don't sit around complaining about how it smells. I take that garbage and I throw it out and I get rid of it. And you know what happens? The smell goes away. So it's like, what is the thing that is causing that smell? And it is our inherent disrespect for using our type system when it comes to errors. Yep. Instead of using the type system to build errors that are concrete types that we return, like literally everything else you return, we return this black hole that might have literally anything come out of it. Right? We're like, oh, I don't know. It might as well be any, right? You might as well just replace comma error with comma any, because that's about as useful as it is. And it's like, if we don't fix that, then we're not going to fix anything else, right? So we need to fix that. We don't need try. We don't need question mark. We don't need any of that crap. What we need is to treat errors as values, right? That's a Go proverb. That's what Rob Pike has said the entire time. Errors are values, and none of us have been treating errors as values. All of us have been treating errors as something special because we don't treat any of our other values like this. We're not returning a useless garbage interface for our other values. No. We're returning good concrete types. We're returning things that are well documented.
Your constructors are returning pointers to actual structs that you want to use.
We're making it obvious if we make a breaking change. I can't just start returning a different type from my functions. I'd have to declare that, and that would be a breaking change, and the compiler would catch that. You can't do that with errors. There's no way you can do that with errors.
I'm getting fired up now, and I have to go soon. This is so annoying.
But like it's not just that, right? It's like everybody is doing this because the other thing that you're doing with this silly, smelly, disgusting error interface is you're collapsing the entire domain of errors into a single channel. And this is what basically every language does. Rust does this. It's not, value. It's not a sum type of a value in multiple errors. It's some type of value in one error, and you got to pick what one error you're going to return
per function call. Yeah, you get one. You get one.
But you're still collapsing everything down into a single channel, and like that does not make any sense because a function could return multiple.
What do you mean
by
channel there?
Like not channels and Go channel, but channel in the general sense of like you're squeezing everything down. Union would be another word you could use, right? Okay. Here's a good example, right? Let's say that you have something that's making a network connection, right? So you make a network connection and then also does TLS on top of it, right? Right now, if you have that, you can return an error, and the error could be a network error or it could be a TLS error. But you can't really distinguish. Like, let's say that you had a TLS error and then the connection got closed. How do you actually return both those errors to the user? You have to make some new type of error or something. But like that's not how we do anything at Go, right? If you had two different values you need to return, you don't try to make a union value, you return two values. So in this case, you should return two errors. I should be able to return my network error. I should return my TLS error. These should be separate things. That's how it should work in Go. That's how everything else works in Go. That's why we have multiple returns. This is another unique feature of Go that would solve a lot of these problems. We wouldn't be
trying to... So are you saying like in this case, like if I have a function that returns the type that I want to work with, and then like a potential of 3 errors, do you do like, return foo and then 3 error values?
Yeah. 3 different error types. Yeah.
Yeah.
Which I know there's probably a lot of listeners being like, that sounds insane. Yeah, so does multiple returns. So like that's why we have multiple returns. It's so we can return multiple things. And you know what? It probably is kind of smelly if you're returning 7 different errors.
But like, does it really sound insane though? Like, ding. Man, I have to go soon. Does it really sound insane though? Like, think about it. Okay, I don't return multiple errors. I instead I'm in a call path that can return one of these 3 errors, and I have wrapped them up in custom types, and I return 1 error. So my caller now has to unwrap it and compare it against all those different types anyway, but it has no way of knowing what potential types there are to they can't enumerate which ones to do. So you just have to know that. So in your caller, you have it, foo comma error equals function call, and then you take the error and then you say like, var error 1 if error equals errors as error 1, like, you do that for error 1, error 2, error 3. So like you're just hiding the multiple returns in a long if conditional block or whatever. Yes. So instead, if you had multiple returns, you would do like, foo comma error 1 2 3 equals function call, and then like you can just do if error 1 does not equal nil, if error 2 does not equal nil, if error 3 does not equal nil. Like is it different? Right? Arguably it's cleaner in a way, because now I don't have to do the errors as, because I'm passing you the concrete error type already.
Yeah.
Like I'm passing you that back as a return. So you don't have to do any sort of like, let me initialize a variable and then, type assert to this and blah, blah, blah. You can just use it.
Yeah. Yeah. The thing about the error interface is that it is unbounded. Like, unless you are package main, you have no way of knowing what might come out of any error interface.
Yep.
You cannot determine that even with static analysis, because you don't know. You can't definitively know that like some dependency might got moved around or something that returns different errors. Like you cannot know unless you are package main, which is just not a great place to be, and not what we find acceptable for literally anything else in the language, right? I think here's a definitive statement. I think we should deprecate the error interface. I think that thing should go. There's my unpopular opinion for this episode. That thing is causing us causing our language undue amounts of smell.
And then you just pass structs back. Like you just make an actual concrete struct that says foo error, and like, that's it. You
need to handle errors just like you need to handle your regular values. You need to be in control of your call graph and of your code. You need to be returning cleanly things up, because that's what we expect of everything else. Errors, like when it hit me the other day when I thought about this, of like, Rob Pike told us errors are values. And then I was like, oh, but errors are values, as in errors are not something special, as in they are just the same thing as everything else. And it feels like none of us have actually internalized that. And it's like we spent years and years and years and years all arguing about the different, how do we make this smell be less smelly? And it's like, you know what? You make the smell be less smelly by taking the garbage. You take the rotting garbage out of the house.
And like, interfaces are generally used for behavioral things.
Yes.
And errors don't have the same behavior, because there might be an error that the behavior you really want there is to panic the system, or another error that you want to recover from, or not. Like you want to handle these things different, so they don't actually behave the same in a way.
Yeah.
Right. Like, yeah, it's pretty interesting. Okay.
I mean, when you think about it too, like the type of thing you might get out of error too might literally just be a value, right? I think a good example is SQL error no rows. Like, if you're expecting no rows, then that's not an error. That's the value you want. That's the value you're expecting.
Yeah.
Or IO EOF. That's another one. That's not an error in all cases, or in many cases.
Because you can return n number of bytes read plus IOEOF because you hit the end of the file. And
that's information.
Correct. Yeah.
So it's like we already have values in that stream of errors, but now there's also just like errors in it. And like, yeah, at the end of the day, the most responsible thing most people can do is just either lazily wrap it so you have some level of stack tracing, I guess, or just throw the thing up the stack, which makes it smell, which is not what we do with most of other stuff. We return composite types. Oh, I call my dependencies to gather all of this because I'm building an abstraction. And all of our abstractions just go out the door as soon as you're dealing with error handling, or the unhappy path, as some people might say. And it's like, but that's like most of the path. Like that's like most of the stuff, and some of the most important stuff is in that error handling system and path. And like we as a language, as a community, have just never treated that well.
Right.
Because we're all stuck with this interface, because it's just easier for all of us to say return error. Like so many times I've gone to write something and been like, this thing right now, how they've implemented it, would never return an error, but it might in the future. So let me put that error there. So if I decide to return an error in the future, I can. What kind of crazy thinking is that, right? Because you're like, I don't know, dude, this thing might just start spewing something back at you that you have no idea how to handle.
It's also like, there's a breaking change thing to be had here. Because I know people would be like, oh, if you add an extra return value, it's a breaking change. Yeah, but also if you add a new error that's returned blindly, that's also technically a breaking change.
Should be a breaking change, yes.
Right, like because if your user's trying to like errors, assert on like error foo, error bar, like they don't know how to. They don't know that you just added error bars.
And like what we usually be the backstop of that is, oh, I'm returning an interface. Yes, but that only is legitimate if the user can use the interface and get something useful done without having to look at the concrete type. Which when it comes to errors, if you want to actually handle an error instead of punting it all the way up the stack and then just logging it, like then that interface is not sufficient. In the same way that like if you want to like have a reader and you want to do buffered reading, or you want to be like, I want this to be buffered, or I want to do bytes, like there's other interfaces you should use. There's other things you should try. You can peek under the hood when you need to peek under the hood, but you're recognizing that when you peek under the hood that interface is leaky. And the fact that we built an entire part of the standard library about peeking under the hood of errors so we can kind of grab at what's underneath it is the tell that we're not using this as an interface. We're using it as a garbage bag, holding a bunch of garbage that nobody ever wants to deal with. And all the garbage stank is seeping out of it. And we should fix this. And that's probably one of the hardest things we as a community will have to do, because there's nothing that anybody else can do for us. We all have to sit down and actually think about types, and actually think about errors, and actually think about that part of our call graph, and actually figure out what the heck we're going to do with it. Right. Because we just have not been doing that this entire time. And that's why this whole problem is so messy. But again, this problem is messy for the entire industry. It is not us. It's just us that has the smell that everybody can smell. Everybody, all the other languages, they kind of hide that smell. They have the Febreze on automatic spray. We just don't got that. So I
like this. I want to dive into this a little bit more too.
Yeah.
So I have to drop though, because I need to catch a train, because NJ Transit is not the best. Unfortunately, but I want to continue this conversation because I want to think on it too. I want to actually think on it, because you're right. Like, here's a language of multiple return values. Oh, but just don't use more than 2. It's like, then why? Why did you put it in here? So I want to talk about this more, but we'll let it settle.
Okay. So yes. So viewer/listener, what'd you think about that? What you think about that whole conversation about errors? Did what I say, is it jiving with you? Or are you like, nah, Kris, you're wrong. The error interface is fine. We shouldn't deprecate it. I mean, you're wrong. But let us know your thoughts. Let us know what you think about that. This episode of Fall Through was hosted by Chris Brando with co-host Matthew Sanabria. Fall Through is produced by Chris Brando, and our beats are by Breakmaster Cylinder. And done.
Nice.